Geometry students, here are the proofs for your final. They obviously won't be exactly like these, but you can count on a proof that will be from each of these learning targets, so they should be similar. Here you're using either the angle addition postulate or the segment addition postulate to prove something. So after the given, and that in this case is that angle ABC, the entire thing equals 68 degrees, prove that x equals 8. Well, the first thing you're going to do after you write down the given is use the, in this case, angle addition postulate to take this plus this, and that equals the whole thing. Your justification is the angle addition postulate. The two angles added together equal the whole angle. At this point, you're just kind of using some algebra to solve for x. You can use the distributive property first, so that's where the 6x plus 12 comes from. Again, justification, distributive property. And then you combine some like terms, the 12 plus the 8 is 20, and then you subtract the 20 from both sides, so the subtraction property of equality, and then you divide both sides by 6, and that would give you 8 for the division property of equality. And that's what you were trying to prove, so you're done. Let's see here, a parallel line proof. So you're given that A and B are parallel, and then you need to prove the alternate interior angle theorem. In other words, that angle 1 is congruent to angle 2. Well, you can't use the alternate interior angle theorem to prove the alternate interior angle theorem. That's got to be something that you know at this point. Here's what you do know. You know that 1 and 3 are supplementary. And that's by the same side interior theorem. When you got parallel lines cut by a transversal, the same side interior are supplementary. And then you know that 2 and 3 are supplementary, and that's the linear pair postulate. 2 and 3 are a linear pair. That means they got to be supplementary. So linear pair postulate. And, well, you can see here that both angle 1 and angle 2 are supplementary to angle 3. That must mean that they are congruent, and that is the congruent supplements theorem. All right, moving on to the next one, which is similar but distinctly different. Here you are given that 1 and 4 are supplementary. You need to prove that A is parallel to B, the same side interior converse. So again, you can't use the same side interior converse. You got to go somewhere else. And now the key difference here is that, well, I don't know that A and B are parallel yet, which means I cannot say things like 4 is congruent to 2 using the alternate interior angle theorem because I don't know that they're parallel. I have to kind of go on my own. Well, here's what I do know. I know that 1 and 4 are supplementary by what was given to me, and I know that 1 and 2 are supplementary, again, by the linear pair postulate. This makes a straight line, so it's a linear pair, which means they're supplementary. And, well, therefore, again, because 4 and 2 are both supplementary to angle 1, they've got to be congruent to each other. So that's why you see angle 2 is congruent to angle 4 here by the congruent supplements theorem. And, well, because 2 and 4 are alternate interior angles, and we've said that they're congruent, we know that A has to be parallel to B, which is the alternate interior angle theorem converse. All right, moving on to proofs from chapter 4. Prove that triangles are congruent using SSS. So you've been given that AB is congruent to AD. So there's one piece of information that you need. And C is the midpoint of BD. Well, that means that BC is congruent to DC by the definition of midpoint. That's the second piece of information you need, the second clue. The third clue is that AC is congruent to AC. That's by reflexive. And so we've got our three clues. So by SSS, we know that these triangles are congruent. Okay, more triangle congruency proofs. Here it says that E is the midpoint of both AD and BC. Well, I guess first of all, that means AE has got to be congruent to DE by definition of midpoint. Similarly to how BE and C have to be congruent by the definition of midpoint. That's two clues here. Don't say anything like AB is congruent to CD because you don't know that. What you do know is that 1 is congruent to 2, and that's by the vertical angle theorem. And so the two triangles are going to be congruent here. Looks like I forgot to finish this one. By SAS. You got side, angle, side, the two sides, and the angle in between. All right, moving on to our last section of proofs. You had this one recently in chapter 5. I like this one because it has a little bit of everything. It's got right triangle proofs, it's got CP/CTC, so it covers quite a few things. Angle 1 and angle 2 are right angles by definition of perpendicular. And then the two triangles are congruent, or not congruent, but they're both right triangles by the definition of right triangle because I just said that I have right angles in it. So that's the first two big steps, show that you got right triangles. And then the next two steps are, because it's a right triangle proof, we only need to find two things. Well, one thing is going to come from BC being congruent to DC by the definition of bisector. Not angle bisector, just bisector. And then here, AC is congruent to AC, obviously bireflexive. So that's two parts. Now I can say that the triangles are congruent by LL, leg, leg. The hypotenuse would be these dotted lines here, so it's just LL. And then now that they are congruent, I can say that AB is congruent to AD by CP/CTC. All right, finally the last one, an indirect proof. So you've been given that 1 is not congruent to 2. You need to prove that A is not parallel to B. Well, after the given, the first step to any indirect proof is that, well, you just negate what you're trying to prove. So the opposite of A not being parallel to B is that A is parallel to B, and you just write negation right here. Well, if A is parallel to B, then 1 would have to be congruent to 2. That would be by the alternate interior angle theorem. But of course, this is a contradiction. You need to write that. You cannot be congruent to 2 and not congruent to 2 at the same time. So therefore, because the opposite, or the negation, was false, the original thing must be true. And so therefore, 1 is not congruent to 2, or sorry, A is not parallel to B. I made a mistake there. What we're trying to prove, that's what we would put here. And that is by a proof by contradiction. And that's how you finish it out. All right, well, that's it. Good luck on your finals.